Welcome to the final video in this series on balancing redox reactions, specifically looking at acidic solutions. In previous videos we've looked at the first three worked examples, and this video will focus on this lovely reaction between nitrate ions and iodine to form iodate ions and nitrogen dioxide. First step, go ahead and throw in your oxidation states. Oxygen is -2. There are 3 oxygen atoms. That makes the entire oxidation state -6. And then nitrogen must be +5. And we know that because the overall ion has a charge of -1. Iodine is in its elemental form. That is how it is naturally found. So its oxidation state is 0. On the right hand side, iodate ions, we have oxygen, which is -2. There are 3 of them, which makes -6. And that leaves our iodine as +5. And in nitrogen dioxide, we can calculate that N is +4. If we compare the changes, oxygen remains the same. We can assume oxygen is spectating in this reaction. And the key changes are nitrogen, which goes from +5 to +4. It is being reduced. It's becoming more negative. Each nitrogen gains 1 electron. On the other hand, iodine goes from 0 to +5. It has been oxidized. It has lost 5 electrons per iodine. So if we take this formula and turn it into a half equation, let's start with NO3-. I'm going to leave a gap as usual so I can add species in, and that forms NO2. Now, we've already mentioned that there is a gain of a single electron, and as there's only 1 nitrogen, we can leave it as a single electron. There are 3 oxygen atoms on the left and only 2 on the right, so we can go ahead and add an extra molecule of water. And that gives us 3 oxygens. The oxygens are now balanced. The new issue is the number of hydrogen ions. And to get around that, we can add 2H+ to the left-hand side. That gives us our first half equation. The second half equation, this has come up quite often, iodate, in past paper questions. We have iodine forming iodate. In this, we should have account for the fact that there are 2 iodine atoms. So I'm going to go ahead and throw a number 2 in front to say there are 2 iodate ions. As it's an oxidation, there is a removal of electrons, 5 electrons per iodine. Altogether 10 electrons to account for both iodine atoms. The second issue is the number of water molecules. Now there are 6 oxygens on the right hand side. It's 2 times by 3 makes 6. So we can go ahead and say there are 6 H2O molecules on the left. The final piece of the jigsaw for the half equations. There are 12 hydrogen atoms on the left, so I'm going to go ahead and add 12 H+ ions on the right. I think that's fully balanced. Yep, excellent. Now to get the final answer, which is the combination of both half equations, remember we must cancel out all electrons, and currently the top first half equation has only 1 electron, whereas the bottom has 10 electrons. To overcome that, we can multiply the top equation by 10, a factor of 10. And if we multiply everything by 10, we get 10 nitrate ions, 10 electrons, 20 H+ ions, 10 nitrogen dioxides, and 10 water molecules. We don't need to multiply the bottom by anything because they are already the same factor now. And before I continue, I'm going to remove cancel out essentially electrons, H plus ions and water molecules. 10 electrons at the top, 10 electrons at the bottom. There are 20 hydrogen ions at the top, but only 12 at the bottom, so we can remove 12, leaving 8 H plus ions. We also can cancel out water molecules. There are 6 at the bottom. If we cancel out 10, we end up with 4 H2O. And that leads us to our final equation. Let's combine everything together. We get 10 NO3 minus. There's nothing else at the top. Add the bottom half equation reactants, iodine. In fact, I tell a lie, there are 8 H plus ions here, which can be added. And that makes 10 nitrogen dioxide molecules. We're left with 4 water molecules, 2 iodate ions, and that is the entire equation balanced. I hope you've enjoyed and found these videos useful. Coming soon, I'll be showing you slight variation of balancing redox reactions, but in basic conditions. Feel free to subscribe, like, share, comment on any ideas of content you'd like to see. And all the best with upcoming exams